Hey friends, welcome back to our YouTube channel Physics Zone. Today we will move ahead in our chapter of law of motion. Today we will discuss a very important term, impulse. So what is impulse? Impulse is nothing but it's a force that is acting for a short time. In case of hitting, catching, diving, kicking, we can find here that a large force is acting for a very short time. Here, impulse comes into play. Okay, impulse can be defined as impulse is the force is a impulse of a force is a measure of total effect of the force. Okay, so it is the definition for impulse. Impulse can be written as impulse is equal to average force into time. Okay, this is the formula for impulse. Impulse we can derive from second law of motion. According to second law of motion, F is equal to dp by dt. Okay, now we can write it as fdt equal to dp. If we integrate it, dt from time is changing from 0 to t and momentum from p1 to p2. Okay, now f dt will be t 0 to t, and if we integrate dp it will give us p, and it is changing from p1 to p2. Okay, now from here f is the average force, so we can write f average into t equal to p2 minus p1. So from here we can say impulse is nothing but the difference between the momentum that is changing from one place to another. Okay, and f into t is impulse, that is equal to p2 minus p1. Okay, so we can write its SI unit and its dimension formula. And one more thing, that is impulse is a vector quantity. We know impulse is equal to force into time, and force is a vector quantity, so impulse will also be a vector quantity. Okay, from here if we say its SI unit, impulse equal to force into time. SI unit for force is Newton, for time it's second. So SI unit for impulse will be Newton second. Okay. Dimension formula for impulse will be Newton. For force dimension formula ml t minus 2, but here one time is extra, so m1 l1 t minus 1. So this is the dimension formula for impulse. Okay, now we can also find impulse if we have given a graph between force and time. Here is the graph for force versus time. Okay, if we have given this graph, then we can find impulse by finding this area. Okay, we know impulse is equal to force into time, and if we find the area under this curve, then it will give us impulse. Okay, and we can also write it like as f dt. From time is changing from t1 to t2. This will give the area under the curve. Okay, and this is the impulse. Okay, we can discuss some examples for impulse. You have seen a cricketer, or when he catches the ball. Here is a player, cricket player. Okay, a, he sees a ball coming. Just a second. He sees a ball coming from here. Let's its momentum is mu here. This ball is moving and he catches it. Okay. If he catches it and stops at the place, its velocity will change. Let's see. The change in momentum from here to here will give us impulse. Okay. What if he changes its momentum slowly? We know impulse is equal to force into time, that is equal to p2 minus p1. Okay, we know its momentum will remain, the change in momentum will remain same, so impulse will be same in every case, because we can't change its speed. Initial speed is mu, its initial speed is u, so its momentum will be mu, and we have to stop it. Its velocity will be 0, so we can't change its impulse. Okay, so means impulse is same for every condition for this case. Okay, but if we catch this ball and stop it at a place, its impulse will be large, because here the force is very large, so it may cause injury in player's hand. So to protect the hands from injury, what should we do? If we decrease if we decrease this force, then hands can be protected from injury. This is constant, impulse is constant, and we have to decrease this force. Then what can we do here? If we increase this time, then the force can be decreased and hands can be protected from injury. Okay, so when player catches this ball, he will take this to this side. He will give this ball some time for changing its momentum. So this increase in time will decrease this force. Okay. So this is the reason why players take his hands down while catching the ball. Okay. I hope you understand this. There may be some more examples of impulse. Like as china wares or glass wares are wrapped in a paper of straw pieces. Why? If they fall, consider a china ware pack fall down. If it is not in straw pieces, it will face a large force, and these may break. But these are in straw pieces, then the time can be increased and force will decrease. Okay, like this, the china wares can be protected by using straw pieces. Okay, we can discuss here one example, one numerical. Okay, the numerical is like this. So the question is, a hammer of mass 1 kg moving with a speed of 6 meter per second strikes a wall and comes to rest in 0.1 second. Calculate impulse of force, the retardation of the hammer, and retarding force that stops the hammer. Okay, this is the question. The question is saying mass is given, initial speed is given, and finally the hammer will stop. So its velocity in final will be 0 and time is given 0.1 second. Okay, so mass equal to 1 kg, initial velocity 6 meter per second, final velocity will be 0 because the hammer is stopped up at the final, and time 0.1 second. Okay, now we have to find impulse of force. We know impulse is equal to force into time, and that is equal to P2 minus P1, means momentum change. So we don't have force, but we have momentum, means we have mass, we have velocity, so we can find momentum, and momentum change will be equal to impulse. So from here, impulse is equal to momentum, final momentum is mv minus initial momentum mu. So mv, m is 1 kg and v0 minus m 1 kg and u 6. So from here we can say impulse is minus 6 Newton second. Okay. Now retarding force that stops the hammer. We know impulse is equal to force into time, so we can write force is equal to impulse upon time, and we have found impulse is 6 and time given is 0.1 second. So from here we can say force is equal to 60 Newton. Okay. Now we will find retardation of hammer. We know force is ma. Okay, and this is 60 Newton. We have found it. Mass is given. So acceleration from here will be 60 upon mass 1. Okay, so we can write it 60 meter per second square. Okay, this was the numerical about impulse. Okay, so thank you for watching my video and have a nice day.